Okay, let's revisit question 2C. Run a one variable statistic on the height data provided from the class. Note, we have every data point, so we use the population standard deviation. If we had a sample from a larger data set, we would use the sample standard deviation. So we did our one variable stat. We determined that the mean, x bar, was 164.6 centimeters with a standard deviation, population standard deviation, of 6.27 centimeters. Remember, whatever your unit of measure is for all your data, your x's, your inputs, that means that your mean is going to use the same units of measure, and your standard deviation is always going to use your same units of measure, which in this case is centimeters. So let's go to our graphing calculator. Now, the first thing we did, we store 164.6 as x. That's our mean, technically x bar, right? We store 6.27 as p for population standard deviation. Now, what we're going to have the calculator do for us is determine what each of those standard deviations match to when we move away from the mean. So if I add one standard deviation to the mean, I'm at 170.87. When I add two standard deviations, I'm at 177.14. When I add three, I'm at 183.41. So now I have four pieces of data for my table. Let's go to the other side of the mean. So x minus p, one standard deviation to the left, brings us 158.33. Two standard deviations, three standard deviations. We'll put all this onto our model. So if we take a look at our model, our mean right here is 164.6. And then we have our standard deviations. One standard deviation to the left, two standard deviations to the left, three standard deviations to the left, and the same thing to the right. So now we have this all set. We want to go through and put our data points in. Before I go there, though, I want to talk about x1 minus x bar. Remember, if you notice right here, these are absolute value symbols that I have outside these calculations because we never have a negative distance. Your distance from one point to another, the smallest you can ever have is 0. So here, when we subtract, we want to make sure we do the absolute value to always keep these positive. So their person that I used wasn't actually somebody in our class. This was another teacher who you may see in the building from time to time. And he was actually 191 centimeters. So he was 26.4 centimeters away from the mean. This is me at 165, and I'm only 0.4 centimeters away from the mean. So let's go ahead and put these two data points on our graph. I'm going to start with Mr. Brooks. So if I look at this giant purple arrow, I notice 1, 2, 3, and then way over there is Mr. Brooks because he may be the tallest teacher in the building, right? And that, so the way that I would describe his height compared to the group is Mr. Brooks is 1, 2, 3, more than 3 standard deviations above the mean. Now, I chose to include Mr. Brooks's height to make a point that sometimes you can have these extreme type of situations, but realistically, in a model like ours, this will almost never happen because Mr. Brooks wasn't part of our data set. If he would have been included in our data, our standard deviation would have been larger, and therefore he probably would have fallen into the from 2 to 3 standard deviations. But since he wasn't a member of our data set, he was really extreme over there, but I thought it would be fun to include him in the data. So now let's look at me. My data point is almost right on top of the mean. I'm definitely included in this inner group right here in the middle. So my description is plain and simple. I'm less than 1 standard deviation above the mean. So remember, we were able to create this entire model just using the mean and standard deviations away from the mean. And that's how we're describing our data points in that. So one other thing I want to touch on. If we go back to our vocabulary key, we've discussed the mean. We know exactly what that is. Now the sample deviation, that's like you did in the ticket out the door. When you have some data, but you don't have all the data, you use the sample standard deviation, which is always a little bit bigger than the population deviation because it gives you more room to play with, right? Since we had all the data, we use population standard deviation. What I'm talking about today are typical values. So definitely, if we go back to our model, my height would be considered typical for our class. And the way that I want to identify a typical value is generally fairly close to the mean. So how can we get specific about what we consider fairly close within 1 standard deviation? And that's why we're calculating standard deviations. So if you've got 1 standard deviation below the mean or 1 standard deviation above the mean, anywhere in this entire range, that would be considered a typical value. So in this case, anything between 158.33 and 170.87 is typical for our class, unlike the Mr. Brotz's that are way over there at 191 centimeters